In this video, we will be looking at the timer function and also sending text to the terminal. We start by creating a new C++ project and name it my UART. For the board selection, we will again select the EK-RA6M4 based evaluation kit. From the board menu, we find the EK-RA6M4, and once we have selected, we can see the microcontroller with 144 pins have been selected. And then we click Next. We select a flat project with no RTOS selection and a bare metal minimal template. And the project is loaded. An RA6M4 chip is now ready to be programmed. From the RA6M4 datasheet, we will find that there are 10 Serial Communications Interface SCI ports, which is also known as UART. In order to configure these ports, we need to navigate to the Pins tab. We then navigate to the Peripherals. From here, we can find the Connectivity SCI option. Underneath that option, the 10 ports are available to configure. As we click on each of them, the respective pins are highlighted. We select the port SCI5 for this project. By default, it is disabled. We can enable the asynchronous UART mode. Once we have enabled the asynchronous UART mode, the associated pins with this transmission will be activated. In this case, which is P501 and P502. When we zoom in the Visualization tab, you can see these are the pin 115 and 114 on the chip. We now make use of the stack associated with the UART communication. We click on the Stacks tab. By default, the I/O stack is selected. We need to find the stack that contains the modules for the UART communication. We click on New Stack. We find Connectivity and we look for UART, which is here. Once we click on the UART, the associated modules will be loaded. Now we have to configure this stack for the port we are going to use. We go into the Properties tab. We look into the Module and General. Since we are using the SCI5 port, we can name it G_UART5 and the channel we name it 5. The rest we can keep as they are. Once that is done, we go back to our stack. If we were to use another port, we can add a new stack from the same option. This adds a second stack and we can configure it for another port if we would like to. But for this project, we would just be using one port. Next, we open the hullentry.c file for further coding. Now that we have configured our stack, we need to generate the project content. There are some configurations already done in the file. we will be mainly looking at this part, the function hull entry, and that says add your own code here. We start by creating a while loop. We then navigate to the Developer Assistance menu on the left. Under the UART menu, we can find all the functions available with this stack. In the next video, we will look at the coding of our EK board to print using the UART method.